Okay, so last video we left off here, and this problem covers problem type 6 from from here. So given a position function, find the velocity function and or the acceleration function, and use the physics version of Susan's table to make determinations about the motion of the particle. So here's the physics version of Susan's table. Position, velocity, acceleration. Position is just the original function. That's the first derivative. That's the second derivative. Okay, and even on regular Susan's table, this would be position, this would be velocity, that would be acceleration. All right, so you could use, you could switch between them. Okay, and now I had to sneak in here change direction, where the particle changes direction. So the first thing they're asking, so this is the position function. They're asking on what intervals the particle is moving right or left. So you have to know, okay, so up or right would be positive velocity, left or down would be negative velocity. And velocity is the first derivative, so I have to take that. So the velocity function, velocity anytime t, is 6t squared plus 12t minus 18. And to figure out where velocity is positive or negative, you've got to use a number line. So first you get the critical numbers by setting it equal to 0. Well, let me factor this because it's going to help to look at the factored form. So 6t squared plus 2t minus 3, that's 6t plus 3t minus 1. Okay, so that's the factored form of the velocity function. And then, so it's going to be 0 when t is 3. Okay, so t equals -3, t equals 1. But, guys, we don't really have negative time. We don't think about negative time. So, excuse me, when we're on the number line, I'm just going to be using that. So, here's the velocity number line. And it'll start at 0 because we don't have, these are time values, and we don't have negative time. All right, so it's really just this, 1, which is my critical number. And then for testing points, I could do 0.5 here, and I could go 2. And then if I plug 0.5 into here, I get positive times negative. So that's negative. And if I plug in 2, I get positive. All right? So that means for part A that the particle is moving left from time 0 to 1. And then it's moving right from 1 to infinity. Okay. And then they ask part B, they ask where when the particle reverses direction. So it would reverse direction at time t equals 1. Because of the sign change, right? Because that's where we've got a sign change. And guys, you need to be prepared to explain any of these. Okay, so on the test, you might see a problem like this, but I wouldn't just say, when is the particle moving left? I'd say, when is the particle moving left? And then please explain. Okay, now, for part C, when is velocity increasing or decreasing? All right, now, velocity, there is nowhere on this physics version of Susan's table where I have, like, in the velocity column, increasing or decreasing. I don't have that. But remembering that velocity is the first derivative, the regular version of Susan's table, the first derivative, down here we have increasing. Okay, so the first derivative is increasing when the second derivative is positive. So I could find the acceleration, which is the second derivative. That would be the derivative of velocity. And then wherever that's positive or negative is going to be where velocity is increasing or decreasing. Okay, so I need, and guys, if I seem out of sorts, I have a wicked sore throat and a pounding headache, so I'll do my best. All right, so this is, all right, so V prime is 12t plus 12. Right? Okay. And, yeah. Okay, so this is also, this is acceleration. Equals, and I'll just factor it. T plus 1. And then you get, okay, so then for the acceleration number line, which is the same as V prime. Remember, this is, time is the domain, so we're not going to have negative. So here you'd have t equals -1 would be like a critical number, but that's not even on this number line. So velocity is going to be always increasing or decreasing. So let's test a point, any point over here, like 1, for example. Plug it in here and you get a positive number. Okay, so for the answer to part C, velocity is increasing from 0 to infinity. All right. Now, I'm putting in here an extra question. At time t equals 5 seconds, is the particle speeding up or slowing down? All right. Now, if they're asking you if a particle is speeding up or slowing down, for the physics version of Susan's table, you have 2 cases for speeding up. When velocity and acceleration are both positive, or when velocity and acceleration are both negative. And then you have 2 cases for slowing down. When velocity is positive, acceleration is negative, or vice versa. So basically, if velocity and acceleration have the same sign, the particle is speeding up. If they have opposite signs, the particle is slowing down. So what you've got to do is you've got to find both the velocity and acceleration at time t equals 5. All right, so this is the extra question. Okay, so the velocity at 5 is equal to, all right, so this is the velocity function that I already found. I'll use the factored form, is equal to 6 times 8 times 4, okay, which is some number which is greater than 0, okay? And then the acceleration at 5, we also, like, we know here that this acceleration is always positive, so, like, I guess I'll find it. All right, so this would be 12 times 6. I'm just plugging into here, which is also greater than 0. So the answer would be speeding up. speeding up. And if they asked you to explain, you would say speeding up because the v of 5 is greater than 0 and the acceleration at 5 is greater than 0. Okay. Finally, this here. Okay, so this one is a little bit harder than what you'll see on the test, but this covers this last problem type 7. So you'll be given some function like this, and using your knowledge about extrema, points of inflection, points on the original graph, critical numbers, or other things, you need to set up a system of equations to find A, B, and C. So this is page 9, number 92. And I think on this same page, number 91 is a similar problem, so you could practice that. And also, there's a problem like this on the practice exam I sent you, like the very last one. So what they're telling you, you've got f of x is this. They're telling you these things. 0 is a critical number. F of 0 is 4, and 1, negative 2 is a point of inflection. Okay, so 0 is a critical number. How does that help me? 0 is a critical number. Means that f prime of 0 is 0 or f prime of 0 is undefined. Now guys, this is a polynomial, so we don't have to worry about the derivative being undefined anywhere because the derivative is going to be defined everywhere because it's a smooth, continuous curve. So if they're telling you that 0 is a critical number, since this is a polynomial we're dealing with, we know that f prime of 0 is equal to 0. So that's going to give you a that will give you a an equation. So we know this. So let me take the first derivative of this. So f prime of x is equal to 3ax squared plus 2bx plus c. And then I know that f prime of 0 is equal to 0. So f prime of 0 equals, you plug 0 in and you just get c. Okay. Yeah, so therefore c equals 0. So we actually were able to find c just from that. All right, now they're also telling you that f of 0 is equal to 4. So if f of 0 is 4, we don't have to plug, or we don't have to take any derivative for this. They're telling us that if you plug in 0 into the original function, you get an output of 4. So f of 0 equals, guys, if you plug in 0, you just end up with d. Okay, so therefore d equals 4. So we already found c and d. Now we've got to use this. So this is a point of inflection, tells you actually two things. It tells you that f of 1 is equal to negative 2. All right, if 1, negative 2 is a point on the original graph, which it must be because they're telling you it's a point of inflection, then you know that f of 1 equals negative 2. But then also, if that's a point of inflection, we know that f double prime of 1 equals 0, or f double prime of 1 is undefined. All right, just like for this one here, if 0 was a critical number, we knew either this or this for the first derivative. Well, if this is a point of inflection, then either this or this for the second derivative. But the original is a polynomial, so we don't have to worry about this undefined case because all of its derivatives are defined. So we know this. So these are the two things we know here. Okay. Now, we already figured out that C was 0 and D was 4. So I know that f of x, okay, so I know that f of x is equal to ax cubed plus bx squared. C is 0. Okay, so it's this. All right. And then furthermore, I know that f of 1 equals negative 2. So then I go f of 1 equals a plus b plus 4. All right. Therefore, a plus b plus 4 equals negative 2. All right, so here's where the system of equations comes in. Two variables, so we need a second equation with the same variables. Okay, so now I'll use this. F double prime of 1 equals 0. So I've got to take the second derivative. So, so this is what f of x is. So its first derivative is this. Okay, but, I mean, I already found that. I'll just do it from scratch. Okay, so f prime of x is 3ax to the second plus 2bx. Okay, first derivative. And now second derivative, 6ax plus 2b. All right? And I know that f double prime of 1 equals 0. So f double prime of 1 is 6a plus 2b. Therefore, 6a plus 2b equals 0. Okay, so here's your system of equations. So how about up here, I'll solve for a up here. All right, so up there, I'll get that a is equal to, all right, if you subtract 4, you get negative 6. So minus b minus 6. Okay, so it's negative b minus 6, right? Yeah. And then you take this and plug it in for that a down there. Okay, that's how substitution works. So we get 6, negative b minus 6 plus 2b equals 0. Negative 6b minus 36 plus 2b. Negative 4b equals positive 36. B equals negative 9. Okay, and now that you've got b equals negative 9, you could plug it back in up here. Okay, so a is equal to negative 9 minus 6. So a is equal to, that's positive 9 minus 6 is 3. Okay, so we have a equals 3, we have b equals negative 9, c equals 0, d equals 4. Okay, your one on the test will not be that long. Okay, but it's the same idea. You're going to be given a function that looks like this. You're going to be told some information which will allow you to, you know, say certain things, and then you set up a system of equations. Alrighty guys, I'll talk to you later.